Are you afraid of asteroids? This question has two possible answers. Yes, because they can wipe out life on our planet, or no, because they can't hit Earth since we're smart enough to see them coming from miles away and dodge them. But what if you were wrong? And what if one day soon you looked up into the sky and saw a huge meteor heading straight for Earth? What then? If a meteor larger than 50 kilometers in diameter hit our planet, it would be too late for us to do anything. It would explode with the force of billions of nuclear bombs, completely vaporizing everything around it. So let's imagine this terrible scenario. You've just watched a meteor shower with your family, but then suddenly you noticed something odd. One of the meteors didn't seem to be slowing down. At first, you thought it was just another space rock, but then it dawned on you that it wasn't just hurtling towards the horizon, it was flying right towards your city. But when you tried to call for help, you found yourself in a terrifying paradox. Nobody else seemed to notice the impending doom. Your phone rang and rang, but nobody answered. Your friends and neighbors continued their daily routines, oblivious to the real danger. Were you going crazy? No. They just hadn't seen the same thing you had. You look back up to the sky, and the meteor doesn't seem to have changed its trajectory at all. It's still on a direct collision course with Earth. At this point, the authorities should have already realized what was about to happen, but they don't seem to be doing anything to prepare for the worst. Now, you're truly alone. You try to convince others to take cover, but they just laugh at you and carry on with their lives. But you know you need to get out of there. You jump in your car and speed away from the city. But after driving for hours, you realize that there is nowhere to escape. The meteor will impact somewhere on Earth, and nowhere is safe. Finally, the authorities are acting. Emergency sirens blare through the streets and panicked crowds run for the hills. People run into grocery stores to stock up on supplies, but everything is being swept off the shelves in a flash. You grab whatever you can find and rush home to await the impact. As you watch the sky, you feel like the world is ending. But does it have to end like this? Could you have done anything to prevent this catastrophe? Let's go back to the beginning and find out. Before the meteor arrives, you could actually do something to prepare for its impact. NASA's Jet Propulsion Laboratory scientists have even created a plan to stop an asteroid headed for Earth. If humanity had known about the asteroid long enough in advance, we might stand a chance. The first step would be to send probes into space to track the asteroid and study its composition. Then we'd figure out how much time we have before the collision and how fast the asteroid is moving. We'd also determine where the asteroid would impact so that we could decide whether to send people or robots ahead to study the aftermath. After collecting as much data as possible, scientists would develop a strategy to destroy the asteroid. Our best chances would be to use a nuclear bomb or a spaceship equipped with powerful lasers. But how would we actually make this work? Well, it would depend on the asteroid's composition. If it were rocky, we could push it away by hitting it with a spaceship. But if it were made of ice, we'd need a nuclear weapon to blast it apart. But if neither of these options worked, we'd have to change the asteroid's orbit completely. To do that, we'd need a gravitational tractor, which is basically a spaceship that uses its gravity to bend another object's path. Although none of these methods are currently available to us, in the future, they just might save our planet. But what if we didn't have time to prepare? Let's go back to the moment when the meteor was still a mere speck in the distance, but its presence was already felt across the globe. After the apocalyptic explosion, a powerful shock wave would race across the planet, destroying everything in its path. A few seconds later, the intense heat would ignite massive fires that would rage for weeks. Cities would turn into piles of ashes, forests into charred wastelands. In short, the entire planet would turn into one big barbecue. At the same time, millions of tons of dust and debris would shoot into the atmosphere, blocking out the sun and plunging the planet into darkness. All of this would happen within minutes. Then the torrential rains would begin. Every human on the planet would get drenched to the bone, and not a single dry leaf would remain on any tree. The continuous rainfall would last for days and inundate valleys and craters. Water would gush over the land, washing away the remnants of human civilization. Everywhere, tsunamis would roll across the oceans, towering hundreds of meters above sea level. They would slam into coastal cities, annihilating everything in their path. Survivors would be forced to flee inland, seeking refuge far from the destructive power of the elements. Those who managed to survive the initial impact and the tsunami would face a new threat: earthquakes. The impact of the meteor would generate seismic waves capable of leveling entire cities. In less than a minute, the tremors would encircle the globe, causing buildings to collapse and bridges to crumble. If the meteor had landed in the ocean, the consequences would have been even more devastating. Immense tsunamis would have rolled across the water, inundating coastal regions worldwide. Giant waves would have towered over cities, sweeping away everything in their path, leaving behind only a trail of destruction and despair. The very fabric of society would be torn apart, leaving survivors to fend for themselves in a world forever altered by the catastrophic event. But in the end, nature would reclaim what was once humanity's. In the days following the disaster, survivors would emerge from their shelters to face a world turned upside down. The air would be thick with smoke and dust, casting an eerie gloom over the landscape. Homes and landmarks would lie in ruins, serving as grim reminders of the lives that were lost. But amidst the devastation, life would find a way to persevere. Survivors would rally together, sharing their stories of loss and survival. They would come together to rebuild their communities, drawing strength from their shared experiences. But the road to recovery would be long and arduous. Resources would be scarce and the threat of further disasters would loom large. Survivors would need to adapt to the new realities of their world, learning to live in the aftermath of such a cataclysmic event. And that's not even the worst part. Imagine the climate on Earth after the dust settles. Without any signs of life, the temperature would drop dramatically. Sunlight would be blocked by debris, turning Earth into a giant freezer. This phenomenon is known as nuclear winter, which occurs when a massive explosion blasts large amounts of smoke and dust into the atmosphere, blocking sunlight and causing temperatures to plummet. But how low could they go? The exact temperature range during a nuclear winter is uncertain and depends on various factors. However, based on scientific estimates and observations from satellites following volcanic eruptions, it is believed that the surface temperature could drop by 18 degrees Celsius or more, and this would last for several months or even years. Basically, the Earth would turn into a giant popsicle, and only some microorganisms and giant cockroaches would survive. A recent study conducted by researchers from Lancaster University and the University of Southampton suggests that the impact of an asteroid similar to the one that caused the extinction of dinosaurs could trigger an ice age. According to the report published in the journal PNAS, the impact of such an asteroid would initially cause a rise in global temperatures due to the release of vast amounts of energy. However, this would be followed by a prolonged period of cold weather lasting up to 10,000 years. The researchers used computer models to simulate the effects of an asteroid impact on Earth's climate system. Their findings suggest that the impact would cause widespread wildfires and massive carbon dioxide emissions. But as the dust and debris settle, they would block sunlight, leading to a significant drop in temperatures. This climatic shift would persist for thousands of years, potentially causing an ice age. But what if this happens again? When will the next apocalypse arrive? Don't worry, we're not doomed just yet. The probability of a massive meteor hitting Earth anytime soon is incredibly low. According to NASA, there are approximately 25,000 near-Earth asteroids ranging from 140 meters to 1 kilometer in diameter. While a direct impact from one of these asteroids is unlikely, there's always a chance that a rogue asteroid could be hurtling toward us undetected. There are also comets that could pose a potential threat to Earth. Scientists continuously monitor near-Earth objects to identify potentially hazardous ones. Currently, there are no known asteroids or comets that pose a significant risk of impacting Earth in the near future. However, the possibility of a long-term threat remains. As technology advances, we continue to discover more near-Earth asteroids, expanding our understanding of the risks involved. Organizations like NASA's Center for Near-Earth Object Studies actively work to detect and catalog these objects. But despite these efforts, the vastness of space makes it challenging to spot every potential threat. Moreover, predicting the exact trajectory of an asteroid requires precise observations. Any slight deviation in its path could alter its course, potentially redirecting it toward Earth. This unpredictability adds to the complexity of assessing the true risk posed by near-Earth asteroids. And don't forget about other celestial bodies. Saturn's moon Titan is the only object in the solar system other than Earth with a significant atmosphere. Its atmosphere contains essential elements such as hydrogen, methane, and ethane, making it a potential candidate for hosting life. The discovery of organic molecules on Titan suggests that it could serve as a cradle for extraterrestrial life. While the extremely cold temperatures on Titan pose a challenge, the presence of liquid water beneath its icy surface offers a glimmer of hope for life's existence. Do you think humans could survive a giant meteor impact? Or would we be wiped out along with many other species? Leave a comment below, and that's all for today. See you soon.